Hello everyone. Today we will be taking a short video presentation on the topic chemical machining. Before we go further into our topic, it is important to understand what is machining. So, machining is a manufacturing process which is used to produce different products, parts, and designs by removing layers from a workpiece. There are several types of machining that includes the use of power-driven set of machine tools to chip, cut, and grind, or to alter a workpiece in general to meet our specific requirements. So, machining process can be broadly categorized into two. So, that is conventional machining and non-conventional machining. Conventional machining includes some common processes such as turning, grinding, milling, etc. Sharp point cutting tools such as taper tool in lathe machine, for example, is used for tapering, and they are employed in this technique for machining. And non-conventional machining includes some sophisticated methods such as electron beam machining, electrochemical machining, etc. So these traditional machining processes are based on the idea that the tool is tougher than the workpiece. But how some materials are too hard or too brittle to be machined using such traditional processes, which is why we mostly go for non-conventional machining processes to get that precise and complex design to meet our specific requirements. So now our topic of interest today is chemical machining process, which is a type of non-conventional machining. Now, chemical machining is the material removal process for the production of desired shapes and dimensions. It is done by a selective or overall removal of material by a controlled chemical attack with acids or alkalis. The metal is slowly converted into a metallic salt by chemical reaction and is finally removed in this form. Areas from where the material is not to be removed are protected by an etching resistant material. So this chemical machining process was developed in the early 1950s, and it is one of the oldest and advanced machining processes and have been used in engraving metals and stones, in deburring, and in the production of printed circuit boards and microelectronic devices. There are different types of chemical machining processes. The main ones are the chemical milling process and the chemical blanking process. So the chemical milling process is used to produce shapes by selective or overall removal of metal parts from a relatively large surface area. The process has been used to wide variety of materials with depth of removal up to 12 millimeters. And the chemical blanking process is similar to the blanking of sheet metals. Typical applications of the chemical blanking process includes the burr-free etching of printed circuit boards, decorative panels, and thin sheet material stampings, as well as the production of complex or very small parts. There is also one another process which is called the photochemical blanking. It is also called as photo etching or photochemical machining. This is a modification of the chemical milling process we have discussed earlier. So the material is removed usually from a flat thin sheet by photographic techniques to first produce a mask followed by chemical machining. Complex burr-free shapes can be blanked on metal foils as thin as 2.5 into 10 to the power minus 3 millimeters. This process is also used for etching, such as for electrical connectors or pattern plates, reflow, or paste soldering. Now, let's look at why chemical machining is preferred over other machining processes in fabrication of different sophisticated materials having complex designs. So the first point is the process is relatively very simple. Chemical machining process literally is done by spraying an acid which dissolves the layers of material, and the process is thus simple. It can be applied to almost any material. Almost all materials from metals to ceramics can be chemically machined, and it is not limited to specific materials unlike other machining processes. Thin sections, and the next one is the several components can be produced simultaneously. So chemical machining process is usually used to produce complex designs which are of small sizes. Therefore, different varieties or different designs of same material can be produced simultaneously, which is economically feasible and has a greater advantage. over the other machining processes. This process does not distort the already machined components. So if the material has undergone machining process before the chemical machining is applied, it, the chemical machining process itself does not distort the already machined parts. The next one is the most difficult to machine material can be processed. Complex design can be processed with ease using chemical machining process, and high surface finishing is possible. So the material uh, after undergoing chemical machining usually have high surface finishing compared to the other machining processes.
Okay, now let's discuss in detail about the working principle and the working of the chemical machining. So the working principle of chemical machining is based on chemical etchant. An etchant is a mixture of strong chemical acids that are reactive to the metal, which needs to be removed. So when the workpiece is dipped in this particular etchant, and the etchant reacts with this metal workpiece at a uniform rate, and this dissolves this metal into the etchant, and the desired shape is obtained. So in order to obtain this particular desired structure, an element coating which is non-reactive to the chemical reagent is applied, and this particular chemical reagent, this particular coating is known as maskant. So this maskant is applied in a desired shape, and we dip this particular workpiece into the chemical agent in order to remove the unwanted area. So now let's discuss about the procedure which includes in the chemical machining. First, it's the cleaning. So the cleaning is a preparatory process to ensure that the surface of the workpiece is free from contaminants, rust, and other foreign particles. So usually it is performed by high pressure water jets, and other alcoholic solutions are used. And what is the need of this cleansing? Why we should clean this particular workpiece? So this is because the improper cleaning could result in poor adhesion of the maskant, inaccurate final dimensions, and improper dissolution of the metal. And other contaminants like oil, grease, etc., can lead to oxidation of the workpiece. So, and the second step is the masking. So here we apply the mask in uh, previous slide. So here we apply the maskant over the surface of the workpiece in a desired shape. A layer of polymer or rubber is usually coated over the workpiece in a desired shape. So the masking is done to prevent the area which does not require machining from the etching process. And the masking is done all over the workpiece except the area that needs to be machined. So now the third method is etching. So this process is in which the required metal removal takes place, and the after the perfect masking, we dip this particular workpiece into the tank, which is filled with the chemical reagent, and the heater and the stirrer is turned on. As soon as the workpiece is dipped, the chemical agent reacts with the non-masked area of the workpiece, which is highly concentrated, and this begins to react with the metal, and this in turn dissolves this particular metal into the agent. So, and now the final and the last step is demasking. So this demasking process is peeling off the masking after the etching is done. Once masking is removed, the workpiece again is cleaned. Operation were left over. Etchant is washed away and pressurized cold water. And now to the next slide. So now, next slide. Okay. Now it's the application of chemical machining. So This chemical machining has been applied in a number of usages where depth of metal removal is crucial, up to a few microns. So this can achieve machining in a very precise manner, and the surface finish obtained in this process is up to the range of 0.5 to 2 microns, which is impossible to achieve by the other methods. And also another application is it can remove metal from the portion of entire surface of formed or irregularly shaped parts such as forging, casting, extrusion. So this can be applied as a further machining of the process which are already achieved. And another application is chemical machining can is a manufacture of burr-free intricate stampings. And also to the next slide. Okay, now the major industries which the chemical machining is applied as, which includes aerospace, defense, medical, decorative, and other mechanical process, other industries. So usually in aerospace industries, the precise machined materials are needed for the proper working of the equipments. So this particular chemically etched metal pieces can be used in a precise manner, and which improves the quality of the product, etc. And uh, next slide. Okay, thank you. That's the end of the presentation.